All right. Good morning, everyone. Nice to see such a big turnout for such an odd topic, but at least that shows me that AppBlocker is still kicking and still around, even though it's quite old. So, first of all, of course, as usual, many thanks to our sponsors who made this beautiful conference possible. Go check out their marketing stands, ask them any questions, how to use their products, and so on. And with that being said, if you haven't met me already, my name is Jan-Hendrik. I'm currently working for Microsoft as a cloud solution architect engineering, formerly Premier Field Engineer. Before that, I was working for Aldi International Services. If you don't know them, Aldi is an international grocery chain operating worldwide. And of course, this includes some automation to some degree. You don't want to manually handle thousands of systems. At least I don't. My main project is Automated Lab, a solution to help you deploy, lab environments. That's pretty obvious, right? On Hyper-V and Azure. And I'm currently working on supporting Linux natively as well, so that you can not only use Azure as the target, but also libvirt, so basically any virtualization engine on Linux. In the past, we had mostly Microsoft in our portfolio. It's open source, of course, and you can just download it from the gallery. I'm very passionate about PowerShell, otherwise I wouldn't be here, and you probably wouldn't be here as well, and decide state configuration. So if you have any questions regarding DSC, find me after this talk. In this talk, we'll unfortunately not talk about DSC, but about AppBlocker. I'm also passionate about brewing beer, so if you have any questions regarding that, feel free to ask me. I do know a lot by now. I've done brewing since, for 20 years now. I started very early, and I think I gained some expertise in the process. If you can find me in Wacken, you can get a free beer from me as well. Right, so let's get to the actual topic at hand, mainly AppBlocker. So, quick show of hand, who has not used AppBlocker yet? Right, not that many, very good. So, all experts here, we don't have to spend too much time explaining AppBlocker itself. And if you have used it before, AppBlocker has been around since Windows 7. It's built in, used for application control, and you usually deploy it through group policy. You can also apply it locally. And you can use it to effectively restrict or permit apps, scripts, and so on from running. And moreover, what it does, it will force PowerShell in the constrained language mode. So it will help you upgrade your security posture. Friedrich Weinmann has done extensive talks about PowerShell security in the past. So if you need a refresher on AppBlocker and all the other security-related things, feel free to check them out after this session. This session concentrates more on how to get the policies into production in a mostly automated way, apart from, of course, writing them yourself. The good thing with this, of course, is it is fairly easy to implement, fairly in big parentheses. There is, of course, a lot going on. You have to analyze a lot of apps. You have to take a lot into consideration when you're building your policies. So in the end, it's probably not that easy, but at least it's a straightforward process. It's always the same. The benefit of forcing PowerShell into constrained language mode, if it's not clear yet, it will still allow you to script effectively, but it will restrict access to arbitrary .NET classes, for example. So usual techniques like creating a script block object and invoking it will not be possible. So the second part of the title of my talk was pipelines. So what about that? Typically, when we create group policy and in particular apply or add AppBlocker settings to those policies, if we have something like source control that mimics source control, and a release process, if you will, is group policy management, advanced group policy management. Not a great tool, at least not from my experience. I usually don't like to use it that much, and it's a bit unwieldy. So we don't really have source control when it comes to releasing AppBlocker policies. We do have some form of review process, though. So in the past, this is what you might have done. What you shouldn't have done is, of course, creating policies manually, clicking around, adding settings, because this is really not a repeatable process, and rather hard to automate that way. The repeatable and trusted process is important, though, especially if you are releasing to your production infrastructure, right? You need to build trust in your release process as well as in the artifacts, the results that pop out of your release in the end. AppBlocker, unfortunately, is rather notoriously bad to repeatable build, which I hope this little project template solves to some degree. This was mainly born out of necessity. My customers, as Fred can probably attain as well, regularly ask, how can we permit PowerShell? How can we do this? How can we do that? Usually it revolves around restricting apps, restricting PowerShell from running and so on. Most of my customers tend to ask for the extreme measure of removing PowerShell altogether, which is of course not supported. So we have to find some way to secure this thing. One of the very popular settings that we do with AppBlocker is restrict PowerShell 2 from running. So not only the executable, but also the library, which you could import and then run your malicious code without the advanced security measures of PowerShell 5, for example. All the manual steps that we did in the past needed to become automation, which is what I aimed to do here. We'll see later in the demo, through a little module called AppLocker Foundry, we can more or less comfortably generate policy information for us to build into actual policy content. The pipeline itself will be a continuous integration and continuous delivery pipeline. So the continuous integration part, the build part, will build our policy configuration every time a change occurs. So if your administrator, your IT ops personnel adds, for example, applications to whitelist or to allow list or blocklist, or if they add new script publisher rules, for example, publisher rules, then each of these changes is integrated into source control, is essentially versioned, is traceable, and will kick off a continuous integration or build process. The result of this CI build, continuous integration build, will then be delivered in form of a group policy, either creation or update of an existing one, and that's about it. The pipeline itself is based around, or the idea of the pipeline is based around the release pipeline white paper. If you have visited the DSC workshops during this conference, you have already heard about this. It's a model that is really a very good foundation to build upon. As you can probably see, not only for DSC, desired state configuration, but also for other infrastructure-related projects. So I can only recommend you read that after the session. Not right now, of course. Listen to me instead. But it is a good read. It is not that short, so I will try to abbreviate it and give you at least the gist. So it revolves around, roughly, a couple of pillars. The source, your configuration code, your AppLocker content, the build process, testing and releasing the changes. What we want to do with source control on the left-hand side is we want to ensure that we have visibility all the time into who changed what and when did the change occur. Usually, these bits of information are crucial later on when it comes to troubleshooting, but also if you want to track your releases, for example, version your policies, all this kind of stuff only works if you have a decent source control system and decent processes in place, like regular code reviews, for example, pull request reviews, and so on for this whole thing. The build that kicks off ensures that we can catch problems early, like, for instance, policy information, AppLocker policy information missing or having invalid security identifiers. If you have created AppLocker policies before from XML and you are missing a SID, a security identifier, then the policy creation will fail. This is something that we can catch early before we even try to create the AppLocker policy, by just examining our input, our configuration data. The build process is compartmentalized. It's broken up into several smaller units of code, smaller pieces, that make it easier to swap out individual components. Like, for example, validating the code or the configuration data, ensuring that prerequisites are met, like installed modules, install components or features that are maybe required, and so on. All of this is to have a repeatable, trusted build process that always generates the same result each time we build. The artifacts that we are building, in our case, AppBlocker policies, are then tested, for example, due to regulatory compliance. We might want to test in a test environment first to see if there are any outages related to the change, particularly important with AppBlocker, I guess, because it could be a bad idea if you, for some reason, block your business apps from running just by accident. So a separate test environment might come in handy, or at least some kind of pilot org unit where you can test your changes first by linking the policy there first, for example. If you have multiple environments, for example, multiple forests, multiple domains, you might want to check if the change works across environments. It's easy to imagine. So a policy that prohibits PowerShell 2 from running and only allows a certain publisher to run scripts from might be the same across all environments. So we can also test, of course, across all environments. In the end, we are all doing this to release an immutable artifact, ideally automatically, of course. So we don't want administrators to manually carry around the data, release it manually. We would like to make changes without permanent access to the target systems, for example, through through service accounts that run the entire thing. We need someone to sign off on the changes, also probably particularly important with AppBlocker. Before a policy goes into production, we might want someone with management power maybe to sign off on all the changes. These processes are usually informed by the test results, for example. So if you review the results of your integration tests in the environment and can see that at least all the tests that you wrote were successful, then this might be a criterion for signing off on those changes. The releases, again, should be consistent across all environments. So, since we only have half an hour and I bored you long enough, let's go through the demos and see how this really works. I've prepared a little lab environment. Since this is not the beefiest notebook, I hope it all works well, but at least the local part can be done quite easily. For AppBlocker, I've designed a little pipeline template that you can just apply. This is the important bit. So you don't have to copy the code later on when I upload it to the PSConf repo. You can just use the scaffolding brought to you by the PS module development module. So if you haven't had it yet, go check it out. It's by Fred Weinmann. By now you probably all know him. Yeah, why not? Copilot sometimes works quite well. We don't need that one. So install the module. It contains a lot of templates. Not only the one for AppBlocker, but also for other types of projects. For example, module projects, Azure Functions, and so on. We are, of course, using the newly created AppBlocker project. This folder already exists. The way that Fred has designed his module is you can pass parameters to the commandlet invoke psmd template to bootstrap your content. So in my case, I already know that I would like to build out my configuration for contoso.com. If there are mandatory parameters that you didn't pass, then you will get queried by the module. Outpath. Oh, yeah. So short and painless. And if I add that to VS Code, to my workspace, we can already start examining it. The project structure that is created is rather simple. Let me just switch that around a bit. On the left-hand side, under the folder Contoso AppBlocker, you can now see the project that has been created with all the bits and pieces for automation. So before we go through the policy creation, which is the easy part, fortunately, let's quickly go over the build steps. As I mentioned earlier, our build is should be compartmentalized. So we do not want one big monolithic build that is hard to maintain. We'd rather have a simple system that contains maybe different build tasks that we can then trigger in a certain fashion, for example. We have two tasks that are, or 2 bits that are quite important, the prerequisites. Now we need to download a certain set of modules, for example, using the module ps-depend. So the only dependency to your project really is the module ps-depend in this case, which is then used to bootstrap a couple of other modules that we might need in our build process. What these modules do and what they are used for, we will get to later. The last one here, AppLocker Foundry, is a little helper module that ties into this pipeline project here and then generates your configuration data used to create or finally create the policies. The validation step can be used to validate not only the configuration data, so the policy contents, if you will, but also the policy results. So if there's an error in the XML structure, you could validate that. You could also do integration testing. So for example, I believe this one I did include. Yep. You can at least check if the group policy exists using Pester. And if it indeed has a non-empty rule collections property, this at least is an indicator that something worked. It's not perfect. Yeah, you can see we are not checking the policy contents yet, but you could extend it to do even that. That to some degree depends on what you are trying to achieve later on. So the validation is used at several stages along the way. Build and publish pretty much do what they say on the tin. The build process will ensure that the policy definition is getting created and compiled, and the publish process then either creates or updates a GPO with AppLocker settings. So how do all these components fit together then? First of all, of course, let's add that to source control. Initialize an empty repository. It's always a good start. So if you haven't used Git before, first of all, download the Git client. It's a distributed source control system. There are hosted flavors of Git available on GitHub, for example, or Azure DevOps, which I'm using in my lab environment because it's a bit easier for me to demonstrate. But in the end, you will be working with some form of source control. The good thing is that now that your code is in source control, let me see that I'm in the correct path. Yep. We can add and commit our first changes, and thereby sealing them in, and now we can start updating our policies. The central component here, sorry for switching around the windows all the time. The central component here is the configuration data folder. Our policies, much like actual group policies, are made out of single parts. So what this means is that for each target policy that I would like to see in my environment, I will have one small file. The policy might have links configured to certain organizational units with certain settings. This is entirely optional. You could remove them as well. The policy will consist of certain apps that you would like to allow or deny, for example. It is connected to a domain. The domain is contoso.com and is derived from the base name, from the directory that this file is stored in. And the policy, of course, has a name, which is simply the file name in our case. Since the policy belongs to a domain, we can just have a look at the domains folder and examine the contoso.com.yaml file, which, wow, contains a couple of AppLocker rules already. A set of standard rule collections allow loading DLLs for members of the administrators group. All is not enforced, but audited only. Allow MSIs from the CCM cache folder, and so on. A more or less readable list of policy items. Of course, if you remember, generating AppLocker policies is not a great experience. and so is writing these files by hand. So of course, we would like to automate this to some degree as well. You still need to have access to the applications, the Apex packages, paths, and so on that you would like to allow or deny. Like, for example, denying system management automation in an older version. But that's about it. The Git example that's included in this pipeline template is just an example for one application, for instance. So if we scan the program files Git folder for executables and libraries, we can already generate some rules automatically. The project can already be built and downloaded. So let's start with the prerequisites. Also the first part in your pipeline, in your automation. The prerequisites or the prerequisites script ensures that all the build prerequisites are met, which is essentially what your build worker, the little automation bit in your pipeline would do. You don't have to use any pipeline automation. You can still all do this by hand. But of course, the main benefit of using a continuous integration CI tool is that each change in your source control, in your source code will trigger a new build, new tests, and so on. So this is really ideal if you're working in a team of people, all of which are making changes to your policies. There we go. Prerequisites have been downloaded. The module path has been updated. So if we have a look, it's now pointing, well, not really. Let's get to that later. It should have been pointing to the correct path, but that's fine. The module should be importable. We get a list of files, for example, for 7-zip, which I would like to then convert to an AppLocker Foundry YAML file info object. I might have to rename that command at some point because, of course, a get command should not export something. And for some reason, right. The demo gods strike again. I forgot to switch to Windows PowerShell because, of course, AppBlocker is not really great to use under PowerShell 7. Let's try that again. It's a good thing that the prerequisites download, it doesn't take that long. What we're doing here is essentially, if we examine the commandlet getapplocker YAML file info later on, we are converting, or we are using getapplocker file info and converting that to a more readable format that we can then integrate into our source control system and do our linking later. So if I want to add, for example, 7-zip to my policy, I can now do that with one small command. What the hell? Well, the module is there. Let me just import it from here. It's a bit odd that this happened since I tested it yesterday, but there you go. Import module. And we just pretend like nothing happened. Getapplocker YAML file info will produce a new YAML file. At least it did that. Very good. With a couple of rules, all DLL rules, all DLLs, executables that were found, and so on. All file types that are supported by AppBlocker will simply be added, and then you can start updating your rules according to your liking. For example, change the user group SID, remove some rules that you don't need. You do you. We still have to link this, however. So if I now start the validation and build process, we will notice that the new content is not yet included. The validation is always a good step. We want to ensure that our source data is at least syntactically correct, that it should be able to build, even though it might not make sense yet. So I included in this template a couple of basic tests, like, for example, each policy rule has a SID. Otherwise, it wouldn't make sense. You could do some validation as well if the SIDs are valid or not, and update your tests accordingly. It should, of course, convert from YAML without errors, which, if you know YAML, is quite easy to make an error. So if you have a misplaced space somewhere, the entire thing breaks down. And we want to catch that as well, because it happens while writing, unfortunately. This only tests the configuration data. We can, of course, test the integration later on. And let's just, for the hell of it, build the entire thing. It's a quick build. We only have one policy at the moment. And the build process, in the end, will generate one AppLocker XML file. You probably already know that. So if you've used AppLocker before, this file format should be fairly familiar to you. If not, try to export an AppLocker policy and have a look at the output format. This little build process then combines all the different bits and pieces through a module called datum that we have in our folder structure. So let me go back to that for the remaining couple of minutes. The folder structure, of course, contains another couple of components. If you look on the left-hand side, starting with apps, we have our list of individual applications that we might want to allow or deny. In the domain section, we have domain-specific settings that might occur. In the generics, we have some generic settings for Windows. It's a bit redundant because AppLocker only works on Windows, but still you could have a generic section that you would like to apply all the time, like, for example, prohibiting PowerShell 2 from running. Lastly, we have the individual policies, so let me just add a new one, pol2.yaml, because I do want 2 policies, and policy 2 will not only contain Git and OBS, but also 7-zip. Simply by including the name of the new component, the new application in our list of apps. All this merging of different individual bits and pieces is done by datum. If you haven't heard of datum before, you should check out Gail's session yesterday, or just ask him about it. It's a pretty great module for configuration data management, especially if you want to merge and resolve your configuration data, because it is a bit easier if our individual components are more manageable. In the end, we do still want to have a large policy that is aimed at, I don't know, one specific org unit, for example. Through the resolution precedence, I'm not going into detail about the other stuff. That's a bit too advanced for this little pipeline. Through the resolution precedence, we can then configure in which way certain layers are getting applied. Think of group policy links and their order. Certain settings are applied, then might be overwritten and overwritten and overwritten. And we are doing a very similar thing here with datum as well. So we apply our generic settings for Windows. We apply our domain-specific settings. We apply all our app settings through an ingenious little trick here with scripting inside our static file. And lastly, we apply the node-specific settings, so anything that is defined in the policy, like the name of the policy and the link order. All of this is also contained in one resulting YAML file. So once you build the entire project, all the different settings will be combined into one longer file containing all the different rules that we applied earlier. And I think this, at least for me and my little projects that I've used this in, was a big game changer. I can now split up my policy development, make it a bit more readable and accessible, and most of all include it in source control easily, and then update my policies as much as I like. Now that we have added our application, we can of course build the project again. It should be fairly quick. We now get 2 policies, of course. Yeah, we added another one and could now publish the entire thing. Of course, not on my system. So this one I will do in my pipeline, and I think we are good on time. So let's just do that. The publishing can be done using the publish script. If we have a look at this, I mean, why not? We are here anyway. Which does nothing fancy. We will import or examine the RSOP, the resultant set of policy cache, which contains all our policies that were built during the build process. It will then go ahead and search for the group policy, test if it exists. If it doesn't exist yet, we will simply create one. If there are any links defined, we will update the linking and then try. Oh, I can see there is an error here. Policy found. No, it's just a copy. There we go. In the end, we do the last command here, which is set AppBlocker policy. We apply the XML policy to the path here. Of course, this built-in release pipeline is meant not for local publishing, but for publishing the policy to a domain or to a group policy object. If you want a local publishing, you could probably extend that process yourself. It's not that hard, so it's in this case not LDAP but local as a switch parameter to apply this to the local policy. All of this is usually tied into orchestration on in your continuous integration system. In my case, as I already mentioned, it was Azure Pipelines, but really any build system capable of running PowerShell can do this. The project template includes automation for GitHub workflows as well as Azure Pipelines. So if you are familiar with those systems, use them already, you can just get started and import the entire pipeline without much modification necessary. The pipeline is triggered by each commit on the branch main, which is our main productive code. So every time someone changes something to the protected branch, the steps that we saw earlier, prerequisites, validation, build, are simply fired off one after another. So that in the end, we will publish our policies to our domain. So hopefully this final bit works as well. Let me just quickly grab or update the repository, add a remote. Hopefully the authentication works. While I copy things that I should have copied with PowerShell, take your time to think of questions that you would like to ask me. Well, that should work. The unfortunate thing is I forgot to include my credentials in the remote URL. I think it's a bit easier if we just do this on the system. So what I set up here with the aforementioned module automated lab is a little lab environment that is just running Azure DevOps as well as a certificate authority to sign my scripts, an essential component when you use AppBlocker. Yeah. And you have your signing rules. I will zoom in a moment if necessary. Good God. Okay. We just have to imagine that it might work and do the publishing ourselves. So the thing that I would have liked to show, unfortunately, for some reason I forgot to push Git, was the publishing. But since the publish is just a script, we can also just execute it from here. And ideally, since I'm logged on as a domain administrator anyway, yep. This is the build worker. So for the build script, while this is running, the prerequisites are slightly different. If we are on a build worker, we do install some other components because obviously to do the group policy stuff, we need the group policy management tools to be available. We need always to have the appropriate versions of PowerShell get and package management, which we skip on the client. The rest is very similar. We save PS depend and invoke PSDepend with our dependencies. So let's see here, it's still working. Yep, that's good. So that we can publish the policies. At the moment, there are no policies in my domain environment. So what we will be seeing is, of course, some group policy objects appearing after the publishing has been done. And they should be linked to, I think, prod and test, if I'm not mistaken. Oh no, I did remove that, so they are not linked yet. And just created as group policy objects. There we go. Talked long enough to hopefully get the... Oh. Right. It appears that my demo luck has run out. We can still have a look at the RSOP file. Yeah, that looks okay. So I will probably not do any live troubleshooting today, but rather do this privately and update my template if necessary. Yep. Because I don't see the issue here. I did test this, so it did work. We used this at one customer quite successfully with Azure pipelines on premises, I might add. So Azure DevOps Server, even though Azure is in the name, is the on-premises version that you can install yourself. But again, if your build worker runs PowerShell and is authenticated to the domain with the necessary permissions to create GPOs, update GPOs, then the process runs anywhere really with PowerShell. And with that wild ride done, I would like to open the room for a little Q&A, or if you want to see anything, this would be a good time while I'm still here. Yeah, one in the blue shirt. So the question is, would it be a good idea to include this process, if I understood you correctly, into the application repository that you are currently building? It might. So you still need to use the correct file paths after the software is installed. But you could do a scan, for example, for some trusted publisher rules. Yeah, that might be feasible. If your build process for your app repository includes installing the application, you can just hook that in and export the application's information in that step. Yeah. Good question. Thanks. There was yeah. Is AppBlocker supported on Windows Server Core? I don't know off the top of my head. It should be supported. I don't see a reason why not. But I might have to look at the compatibility list. We mainly use this for clients, at least in my customer environments. But I think it is. Yeah, sorry. I have to look that up. These things I just not keep in my head. Yeah. Any other questions? Yeah. Oh yeah. So the question is, we are having a sorry. The question was about the approval by management. This is done through the continuous integration tool. In my case, it was Azure DevOps. So the idea is, if it would have worked correctly, that the group policy objects are targeted at a certain environment. For example, they should be linked to the prod or dev organizational units or domains, whatever. And by using those environments, for example, in Azure pipelines or other tools that support these kinds of settings, we can include some approvals and checks. So if we were to include a approval by our manager, for example, we could include the test results. And every time any deployment hits the production environment, the approval is automatically is automatically started. The reviewer has time to do their approval, and this can, of course, be combined with, let me just initialize this. Why not? It can, of course, also be combined with pull requests. So if you haven't used pull requests before, let me just quickly show you this. Add a new file here in a new branch. And we could include the review process here as well. You make changes to your AppBlocker policies, create a pull request, and then do your code review inside the pull request. Depending on the tool that you are using, you can use something like branch protection policies. They might be called differently in different tools, but in essence, they will always be very similar. And for example, for the main branch, always require at least one reviewer, and check for comment resolution if there are any comments that should be resolved, like, for example, code changes. And you could even include some build validation, like our build process, our validation process that runs to complete and publish test results first before the pull request is even considered for merging. The branch protection policy prohibits pushes to this branch, or you can prohibit pushes to this branch, and it will definitely protect it from a forced push, from accidental deletion, and so on. So 2 ways to do a review, either in a pull request or in addition to that, using an environment. I hope that answers the question. All right. Other questions? Excellent. Thank you very much for your attendance. I hope this project has piqued your interest. If not, I'm very sorry. It will become part of PS module development in the next couple of days once my pull request is done. And I ironed out the last bit that apparently was missing here. But that's how demos usually go. Thank you very much.